So something we can talk about now is function return values, and really a further iteration of function return values than what we've already spoken about. First, I want to begin with kind of a review that there are different ways that different programming languages provide functions to you. It's just something you've got to figure out for each of the languages that you'll be dealing with. It's specified somewhere. You ask the internet, how do I write a function in language X, and you'll figure it out. The shell functions are a bit clunky. You've seen that with the parameters that can be handed into functions. There's this weird $1, 2, 3, etc. syntax, but it's workable in Bash. There's no function at all in the TC shell. The way you go about it there is you just write a different script that does it for you, but there isn't any function keyword. Those would be workarounds, right? Usually, I'd be kind of careful with all of that in the shell, right? It's usually batch scripting or stringing a bunch of batch scripts together that you use shell programming for. It's important to think about how to parameterize your function. Like, what's the stuff that you need to get in from the outside? How many pieces of information do you need to know? If you want to convert something, say a location, from one coordinate system to another, you probably need to know about all of the current coordinates. So if you're in a Cartesian coordinate system, you need to know X, Y, and Z. And if you wanted to convert that into latitude, longitude, and height, you probably need to know something about what the reference frame of that coordinate system is, what height is relative to, etc. Right? So it's important to think about that. It's not that you can't add new things on later, but if you've already been heavily using your function and other pieces of code, and then you do something, you want to use that same function for something new, there's stuff you need to think about. So return values, we've seen the functions that had one return value. It was either a character or string or some numbers. But in Python, you can return more than one value. You can return a list of values. And the way this works here is there's a simple dummy function, def get two values, doesn't take any input, just returns 23 and 42. And in the main part of the code, we call this, we want value 1, comma, value 2, and get two values, and then we print them out, right? So all that's happening is that 23 ends up in the variable value 1, 42 ends up in variable value 2. And when we execute this script that is stored in the file multi-returned, remember that those are all in the listings directory on GitHub. You print value 1, you get 23. You print value 2, you get 42. So you can return more than one thing, and internally this is basically handled as a list that is being given back. It's packaged as a list and then is assigned, unpackaged here, assigned to value 1 and value 2. You can always use more complex types. You can build your own array or list and return my list or my underscore list, or whatever you want to call it here. I have one value, and then you just have to do the unpacking yourself on the receiving end. Here's an example with Python script that has multiple functions. There was the letter grade that we already had. Letter grade, right? Percent above 90%, you get A, etc. And then there's a function that's new now, that's GPA, that takes a list of letter grades and a list of credits that you got for each of these courses with these grades. And internally, it maps grades, A to 4, B to 3, etc. So these are values. And then you can create a variable total points, set that to 0, and iterate, right? Iterate, that's going back to for loops over the letter grades. Okay, so for a counting variable I that is in the range of 0 to the length of letter grades, add to the total points the value that you find. So first look up which letter grade you have in index I for that parameter that comes here. Check what numerical value you get for that letter grade in that internal map grades. We'll talk about this business here in a little bit, and then multiply it by the number of credits for that course, right? And then return a floating point number of total points divided by all of the credits, okay? So an example, import grades 2, right? And then print grades 2 GPA. Let's say you have one course that was 4 credits and you got a B, one that was 3 credits, you got an A, 3 credits and a C, 4 credits and an A, 2 credits and a B. And what is the GPA for this? And now you have a function that gives you a GPA of 3.25 for this. And you can also use, as previously, the grades 2 dot letter grade if you still want to get a letter grade. So that way you can build up useful modules that provide functions, multiple functions that are thematically somewhat related, that maybe reuse functions, their own functions inside of that module. But outside, you now have something like NumPy or SciPy, right? Matplotlib, these kind of modules that provide all that cool functionality that you'll be using. You can write those things yourself for things that you are interested in. Let's say there's 50 functions in grades.2, like that takes up some resources on your machine, or it takes some time to import them all. You can be very targeted in the functions that you import. You can say from this module grades2, import GPA, letter grade, and then you just use the functions as before without the module name ahead of them, calculate the GPA or the letter grade. So now, what is this curly braces A colon 4.0 business that we're using? Remember, up in here, I have this weird variable that I define, curly braces A, 4, B, 3, etc. What is this? This is a dictionary data type. It's an associative array. And really, all you need to think of is that it provides you the mechanism for a lookup table. And that's exactly how we've been using it. So here you get to assign key value pairs where the key can be a string, a number, or any data type, whereas a list requires the key to be the index of the value. So instead of counting from 0, 1, 2, 3 and having to know that to understand what A is, you need to look at index 0, you can look at index A and get 4.0. That's the value of that grade. We're doing this here. We're building our dictionary data type, A, B, and C, didn't include D and F. And then we can just ask, well, what is the value of a grade that is A? And we get returned 4.0, right? So A is our key and 4 is the value. If we use a lowercase a in this case, we get a key error that tells you that this dictionary does not have a key that's lowercase a, so it's case sensitive. If we say grades D is 2 and grades F is 0, and then grades D is 2.0, so we can add to the dictionary simply by assigning values to new keys that we add dynamically to the dictionary. So we've now expanded the dictionary to include D and F, which we initially forgot. And now, of course, I gave the wrong value to D. This is 2.0, so I can fix that and add 1.0, and now everything is fixed. Again, I can also not look into indices. That's not how things are stored. So I cannot use 4 to get at 1, 2, 3, D. F is 4, right? Sorry, it's 0, 1, 2. D is 3 and F is index 4. I can't get to that because that's just not how this array or that dictionary data type, that associative array is set up. These are really useful for any kind of lookup business that you have, or where you have more complex key value pairs than something that can be queried by simply the index.